Good day, we are live. Welcome all to this horticulture webinar. There has been lots of interest in this webinar, and we have participants that have joined from all over the world. Shortly about ourselves. My name is Gins Antoms. I'm Global Sales Director for Aranet IoT product line in Softechnica. And our guest today is Andris Stuks. And Andris is our horticulture expert. Andris helps horticulture companies increase their productivity through data interpretation and through adapting growing strategies. The purpose of this webinar is to explain how sensors can be applied from agronomist's perspective. Although Aranet sensors can be applied, we all know that Aranet sensors can be applied in greenhouses, and data can be collected, and data can be monitored over cloud interface. The question always arises, how do I interpret the data? What do I do with the data? What practical things how do I practically use the data in my operations, right? Andris will elaborate on that in his presentation, and the format of the webinar today is as follows. We will proceed with Andris's presentation, after which we will provide answers to questions which have been submitted before the webinar. We have already prepared answers, and finally we will answer the questions which will have been submitted through chat during the webinar. So all of you, please feel free to send the questions you have, and these will be commented on at the end of this webinar. So, and now, Andris, floor is yours.
Yeah, hello. My name is now Andris Stuks. Some of you might know me, some of you don't. But I'm busy in horticulture already more than 15, 20 years. I don't remember it exactly, but I remember when I first time went in a high-wire greenhouse of tomatoes. Since then I decided that's the thing what I'm going to do for the rest of my life. Regarding the presentation and the scope of the presentation, it is difficult to cover in 40 minutes of a presentation all the knowledge that I have gained about the sensors and working with them. So please feel free to write your questions in the chat, and I will try to answer them after the presentation in a question and answer time, or later on you can get your answers in email. So a little bit about myself. I have a horticultural background, horticultural education. I have worked in many countries as a light use expert for the leading light company Philips. We have been using LED lights for quite some time, and so basically I grew up with Philips, and I have a lot of thanking for them in my experience what I have. But also there I got a lot of questions that I couldn't answer, and that was the reason why I went into the measuring plants and using sensors. The reason for that was that in the different countries we have been using the same variety and it have been having the different performance. And if the same variety at a similarly the same environment performs differently, then you want to answer why. So for that one, the sensors are in great help, and Aranet is a great company with who to work in the means of sensors, because they have all of the sensors in one infrastructure, in one environment. You can have it in your base station, or you can have it in a cloud. You can build API around. You can use API and build your own software for the data interpretation. So, but I would like to proceed to the presentation, so I can explain a little bit more about experience what I have. So, as I said about myself, I told already a little bit about what we do and how we work. At the moment, we are providing remote grow support for the companies in 5 countries at more than 64 hectares and more than 60 climate compartments. And our main crops are cucumber and tomato. And we're also now exploring options in medical crops and in strawberry as well. The difficulty with working in different countries is that there's a different culture, different nature, different climate computers, and if you want to offer the real grow support and real help for the growers, you need to measure what's happening in the greenhouse. We have seen quite some difference in climate computer sensors and their measurements, and one of the things what we have found out is the temperature of the greenhouse sensor is measuring temperature in one spot of the greenhouse, not in the whole greenhouse, and that's why it's difficult to compare greenhouse in Finland with greenhouse in Kazakhstan, because the location of the sensor is different and you will get a different readings. But in general, what we need to measure, so the plant is plant grows based on the driving force of the plant growing is available light. As more light you will have, as more it's going to grow. But there is 9 main parameters what you should measure and monitor and control. And as I said, most important is light. Then combination humidity and CO2 and temperature will be the factors which are going to drive photosynthesis. And the photosynthesis end result will be plant biomass gain. Wind will increase transpiration. Wind can damage your crop. But then if we move from above ground part to the soil, the important parameters are nutrition, like composition, concentration. Then there is water availability, what you can measure as well. Oxygen is necessary for the root growth, and root zone temperature, as the temperature in above ground parts is important for the root development, disease control, and water uptake. So why should we measure, and why should we have sensors and to get some measurements? Basically is that we need to know what's happening with our plants, with our climate. We need to see how our plant is responding to a changing environment. And today's presentation will be more about greenhouse, although the principles apply also to open field crop. And I started to measure, to gather information about plant response to the changing greenhouse environment. And from that one, any of you, by measuring the plant responses, you can build up your insights of plant responses, and at the end you can engineer. You can do engineering on how the plant should be grown in more efficient way. And instead of using black box model where you put inputs from the climate computer, from the plant registration, which says which parameter were better, you have a possibility to make a regression and to see which parameters actually was influencing the plant performance. You can see it as a differences in plant behavior when you change one of the parameters in your climate. And as well, you need to measure the plants, and you need to measure surroundings just to foresee the problems which can come. And you can give plants more water if you see that they start to wilt. You can help them by closing vents when it's too dry or opening when it's too warm. And also you need to gather information to eliminate human error, because if your driving force for the decision making is end result. When you harvest your yield, then it's too late. The problems appear before harvest. It appears in a growing period. Like tomato growing is a process of 65 days from flower to harvested fruit, and in those 65 days a lot of things can happen, and you could track down what exactly happened with your tomato fruit in a given period of time. And same for cucumber. You can do it so your cucumber grows from flowering to harvest in 14 days. Also there you can see what happened. And in most of the cases we see that's a human error in the climate settings or in labor, but that's what we can measure. So when you go in a sensor business, so the difficulty for us was how we should proceed. We started with different sensors from different companies, but there is a lot of things that you need to take in account if you want to start to measure and if you want to start to compare. One thing is what you're going to measure. Are you going to measure the place where your plant is growing, or you will measure overall climate in a greenhouse? So what will be the thing what you're going to measure, where you're going to store it, how you're going to interpret the data, and how you're going to work with it. So the easy task for us was at the end to come to Aranet, because at that time they offered a base station where multiple sensors could be added. When we started with Aranet, we had only 3 sensors available, and there we added load cells, there we added CO2 sensor, PAR sensor, stem diameter, soil sensor. We have added quite some sensors since then. Why should we get more sensors? So the growing is growing in the greenhouse is depending on how you look at it, easy or difficult task. But from my perspective, and as more knowledge you have, as more difficult it becomes. Greenhouse is monitoring and controlling disturbances in greenhouse, and same time that's the necessary evil, like light is necessary, but it have also influence on performance of the crop and performance of the greenhouse. Light is a free energy, but at the same time it can also damage your crop. So the best is to monitor it and steer it. And from external disturbances, we could, with Aranet sensors, we could measure everything but the sky temperature at the moment. From internal disturbances, they have less impact on the plant development and in the growth. But we should be influencing our air temperature, air humidity, light level, and CO2 level. Where light level we can monitor and by the PAR sensor or lux sensor inside or outside in the greenhouse, and steer it with the screening. And air temperature and air humidity, we can do the fogging, we can do venting and heating as well. So CO2 dosing, also that one, quite some in quite some cases I have seen that CO2 sensors which are measuring the CO2 in the greenhouse, or due to the settings how they are made, is measuring every 4 minutes, and then while the CO2 is dosing you get to high levels, or it is not working at all and just giving some error readings. So to keep the greenhouse climate in balance, to get the best out of your crop, you need to monitor the things what you could control, and then control based on your readings in the best manner how you can do it is a climate computer. Because at the end result is what we harvest. It's the kilos, it's the cucumber, it's the tomato kilos, or any other crop that we're harvesting, and we should be trying to make best out of it. If you see that you're at your crop by one sensors reading you are reading one temperature, by your climate computer reading another temperature, it is already alarming point that you need to check which ones is showing right. And for that one we have tested, we often test it with calibrated sensors to check temperature and humidity, and we see that temperature readings in different places of the greenhouse is different, but the sensors usually are measuring right. But you need to decide what you're going to monitor, and then apply your steering possibilities in a climate computer to achieve the climate that you want around your plants. End result, as I said, is the biomass gain. For that one, the result of the balanced greenhouse parameters will be biomass gain. Besides of that, there are also important parameters, the biomass distribution, but biomass gain per unit of biomass and per unit of time is the most understandable term. If you have learned anything about finances, that's like interest over the principal. The principal is our biomass, and biomass gain over the time delta, it's over the minute, is the interest rate from our loan or what our investment in somewhere. So for that one, we are using load cells. We are measuring plant weight and the substrate weight, and from that one we know the water uptake, from that one we know the biomass gain per unit of light, per 24 average temperature, and for that one we can get a lot of useful metrics. As looking at plant weight, you see when your plant is experiencing the stress. And then by using other sensors, you can see why this stress is appearing. And also we need to measure the plant weight to avoid the human error. And human error, I mean cutting the plants, irrigating not on the right time when, let's say, the grower have put the wrong set points in, or something went down in vents or whatever. There can be a lot of possibilities and reasons why something goes wrong, but the first and right reaction is to see that if your biomass stops to grow, and if there is no net biomass gain per unit of time, then you have a problem. So for that one, measure your plants, and most probably you'll be right on the spot with your prediction and planning. But why it is also important to gather information about the plant growth is that we hear more and more about autonomous growing. I have been taking part in autonomous growing contest for tomato growing. We hear about companies who are already controlling climate computer, putting set points in the climate computer based on grower predefined strategies. But quite often we don't know what happened in the greenhouse and why it's happened. So what we can do already with Aranet sensors, we can answer what happened and why did it happen. Like we see that we lost the biomass gain. We lost the biomass gain because of the increase in EC. We didn't make enough irrigation, and that's why the plant used water from the substrate, and EC increased, and that's why we didn't have the biomass gain. From that one, we already can build a prediction based on what we know. We already can predict what's going to happen. Like if we know that our irrigation unit broke down, we know that we will not water. We know that EC in the substrate will increase, and we know how much time do we have to fix the problem. So we have gained more knowledge. But that's if we go in extremes. But if we go on about everyday life, if we know that we apply 20 moles of light per day with artificial light, we have 19.5 degrees of 24 average temperature. We have 2.5 plants of tomatoes per square meter. We have 9 trusses of tomatoes on the plant. We know that fruit is growing in 65 days from flowering to the harvest. We know already what will happen if we will increase temperature, or at which rate we need to increase the temperature if the light sun will increase. So we can grow more balanced crop. And then also you can get answers on why did your blossom and rot appears. Why did your cucumber fruit gets aborted? Why did your gray wall appears on tomato? A lot of useful things, and from that one you can move to prescriptive when you already know what will happen, what you need to do to optimize your yields. And you can build all your own algorithms, so you can use the companies who already is working in this field, and there are quite a few, to make decision support for the grower. That's what we are doing. We do at the moment we do manual decision support, and then you can move towards to decision automation, which is the next step in growing. So about what we have been using and what would be the best setup based on our experience is for sure you need to monitor your plant weight. For sure you need to monitor substrate saturation. That you can do by two means, or by weighing of the substrate, or by using a soil soil wetness sensor or a EC sensor with a volumetric water content sensor in it and temperature sensor, because in many cases water deficit will decrease your yield. I will show you later on how it looks like in real life, in our experience. Then you would like to know not the greenhouse temperature, but the temperature around the part of the plant which is a point of interest. Like you would like to know what is the head temperature, and for that one we have been using now pointed temperature sensor to measure the top leaf temperature and the plant temperature, and we are using temperature relative humidity sensor with a radiation shield, and that is giving the most precise measurements so far what we have seen. And it is passively aspirated sensor, and it is good reference for calculating plant VPD to see when your plant is feeling stress from excessive light. And then since we are working indoors and growing indoors, we would like to measure light, and I would suggest that you measure light inside, because inside light will be the one which the plant will consume, and that we do with a power sensor, but I would suggest to use more than one power sensor, and in best case it's 4 power sensors distributed evenly in a greenhouse, because we see light blockage from the structure, and it is not wise to use only one sensor. Of course you can use a sensor outside. In our practice we use one sensor outside, 4 sensors inside, and then from that one we have calculated what is the average light per year inside of the greenhouse based on outside conditions, and there we see that if you use only light loss coefficient similar for every year, it will not work out, because light distribution, the natural light distribution of the in the greenhouse depends on outside light itself. If it's more cloudy, the light is scattered, and there will be less influences of the greenhouse structure on natural light. While when there is natural sunlight, when the aluminium button is going to block the sensor, you will see less light. Then regarding artificial light, when there was just a top light, it was easy to use a power sensor inside to measure also inside power with all natural and artificial light with one power sensor, with placing that with turned on light you see also artificial light. But since LEDs came in, you cannot do it anymore, because the LED interlight is positioned in a canopy, and that light you cannot measure with a power sensor. So for that one we are using our counter, which is measuring when the light string is on, and from that one we are calculating added light from interlight. We can calculate how much interlight we have, and then we have added some, and then we know how much light we get per unit of time. So this is what we are using for high wire crops. For the other crops like strawberry, ornamentals, or multi-level, the setup is similar, where you can use plant scales for the scales for weighing the gutter or structure where you have your plants on. It's wise to use it, because there you see the changes in humidity, and coupling it with the volumetric water content sensor, you can same time monitor also the biomass gain per day. Like if you know the wetness of the substrate and the weight of the substrate together with the plants, then you know how much weight of the plant you have gained per day. And the same applies also here for artificial light. It's better to measure it with a time when the light was on rather than anything else. One sensor what I didn't mention in high wire crops, but it's also here in ornamentals and strawberries. Like if you grow raspberry, it's good to measure stem micro variations. That will be also indicating factor when you have a lack of water or shortage of water. Stem micro variation sensor is measuring stem diameter 5 millimeters divided over 1600 steps. So the measurement precision is around 0.8 It is 3 nanometers, is it so? It's 5 millimeters divided over 1600. And that's sufficient to see the slightest changes in a water status of the plant. So we are using in a cucumber, we're using in tomato. We have done amazing work with it in determining the blossom and rot appearance and grey wall appearance on tomato. And then if we talk about medical crops, it's the same. We can monitor the irrigation frequency and irrigation efficiency with the load cells or hanging scales. We still measure the air temperature inside the greenhouse. We still measure the light sum by lights on, off, and par from natural light with a par sensor inside. We use volumetric water content to measuring the soil wetness and EC in the substrate, and later on I will show you why it is so important. And plant weight is based on our experience, plant weight is the most valuable and nearly real-time plant response what you can measure. Like if you use any other sensor, you can use a thermal camera, you will look at the plant, you see the plant is heating up, but it is showing only the plant temperature. You will measure EC in the substrate, you will see only EC changes in the substrate, but that's only that one. We will not see what happened with our plant, and weighing the plant is the best option. We have been using also the optical solutions. We have been using cameras to see the leaf angle and calculating it. It works out also really well. It helps to explain the Tugor, and in combination with stem diameter sensor, you see that increase in stem diameter is corresponding with the increase in the leaf angle, so the leaf is stretching up. So you see that root pressure is building up in the plant, the stem diameter is increasing and leaf angle is changing, and also we see corresponding changes in a plant weight. So far in our practice what we have learned is that plant growth monitoring is a good way how to do it, because then you can learn a lot of valuable things. And one of them is, I will find my pointer. Yeah, it is my pointer, is that if the blue line here is relative humidity in a greenhouse, and we could express it in relative humidity, we can express it in VPD, we can express it in a humidity deficit, it doesn't matter how we express it. It is driving factor for the biomass gain trend. So we see the corresponding changes in relative humidity is changing also the biomass growth trend, which you see also if this line is the biomass gain itself, then you see at what moment it switches and when it slows down and when it speeds up. So we are able to calculate which is the best temperature for the given plant weight for growing, and whether the rate of change of humidity will change our growth. And that we see that if we have fluctuations in relative humidity or humidity in general in greenhouse, we will see also quite some fluctuations of the biomass gain itself, where those changes are caused by natural light. That's why I said that natural light is it's necessary evil. It's good, but it is it's making a lot of disturbances which are limiting our plant growth. And in this moment, usually, if you see steep changes of the biomass gain, and if you get below 0 point and if you start to lose plant weight, and that means that you are losing water from the plant, and usually it is pulled out from the top leaf, and this is why on a cucumber in many cases we see that fruit gets aborted even before flowering. So to avoid it, in this case you could use the screening, or if you know that there will be a lot of sun with changing clouds, and if you know that you have a lot of sun, then you would use the chalk on the roof, and you would limit the income of natural light. Then when I told you about using the hour meter for the lights, so this is where we use it. We measure par inside of the greenhouse, and then same time we are also calculating the artificial light is calculated by switching on off, and here you see like steps, and there we know when we switched each of the strings off. In this particular project we have a LED top light divided in two parts, 50-50 top light LED and interlight. And the second switch step is LED interlight. And also that one we have learned that if we switch interlight before we switch total light out, then we get we let more water get to the head of the plant, and we are decreasing So we are increasing our relative humidity relatively slower, which have better impact on the cucumber growth. So why the plant growth is important and why we should monitor it, because from knowing our plant weight, we also can know how much we have put energy in the fruit growth, and how much we have put in the leaves, and then we know what is our biomass distribution and how we could do better next year, in next season, or even in this season. And then we already can know when we had too much fruits on the plant and when the biomass distribution went towards the leaf or the fruit. Like this is one whole season of a cucumber, starting from the planting. So there we see how we start to increase in biomass. So we already know what is the that this one the net starting biomass gain is exponential function, but then also from all of peaks and drops from the peak, we know how much fruits we have harvested, how much leaves, and we know biomass distribution over a period of time. So, and then we see that when we had more leaves on the plant towards the end of the season, to keep humidity in and higher speed, less energy went into the fruit. And when we had in the beginning of the crop, we had not enough leaf, then we had also less energy going to the fruits because we didn't harvest all of the light. So there you can find the trade-off between amount of leaf and amount of fruits. Then I mentioned to you about importance of measuring in a root zone temperature and EC, and in this case I'll tell you a little bit about why it's necessary to measure EC content in a substrate. That's a real-life experience from the grower, where human error happened that before holiday, grower changed irrigation strategy. He decreased the irrigation frequency and gave less water to the plant. And there this black line, which is going upwards, like moving to the top, that's the EC of the substrate. So the previously, when the EC was at a lower level, when it was around 3 in the substrate, the biomass gain was stable without any changes, and it was growing steadily. Also no changes in humidity in air, and the plant was growing great. But then when the EC in substrate increased, we measured biomass increase in huge steps when we started irrigate, and it was corresponding also, so the same increase was visible in the stem diameter. So we already saw that increase the EC difference between substrate and irrigation water, and increase, particularly what we know now, increase above 1 unit of EC between EC in the substrate and EC in drip water is having influence on a formation of the gray wall. That's according to our experience. I would be glad to hear that I'm wrong, but so far we have been right. And another thing is that high EC in general is lowering the yield, and that one we have measured by biomass gain per unit of time, because we saw that here the plant weight is higher than in periods later, but biomass gain per day, it was decreased because of the morning. Because in the morning we're losing around 60 grams. So just because too high EC and too low substrate saturation, we're losing around 60 grams of biomass gain per square meter. And if we multiply over 100 hectares, so 10 hectares, it depends on your project, there you get to substantial losses in the yield. Because for tomato, around 75 to 80% of the biomass produced goes in the fruits. And with increase in with decrease of the biomass gain, your dry matter content of the fruits will increase, but marketable yield will decrease. So we can monetize influence of EC just by seeing the differences in the biomass gain. So the role of EC is huge. Same time, there are also quite some rumors about night irrigations and and fast pre-nights, and that it helps and that it reduces root pressure, it increases fruit growth. Thanks to Aranet sensors, we were able to put everything in one ecosystem and to measure multiple multiple parameters at the same time. And in this case, we were exploring the night irrigation, whether there is an influence of the pre-night temperature on fruit growth. Is there any benefit of it, or is there any benefit of night irrigation? So we decided to measure, and in January, when it's winter, it's limited time, limited light availability, we decided, okay, let's see, is there any sense to do it? So we gave the night irrigation, and we see here is a peak, and those two lines, those are small fruit, which is in the head, second truss from the top, and big fruit is the second truss from the bottom. So that's those fruits actually the second third truss from the top. This is where the fruit should be growing the quickest. And so we couldn't measure any changes with the night irrigation. So we have done those measurements multiple times, and we haven't seen any benefit of night irrigation. And when so we repeated and we continued with those measurements all year round, and even in May, when we should be seeing something because of the too much water lost during the day, too high humidities during the day. So we see that here we lose the biomass. We thought, okay, if we will give the night irrigations, we should be swelling our fruits faster in the night, but it doesn't happen. We still see the straight line and no changes from the night irrigation. So you can explain a lot to yourself what you should do or what you shouldn't. Also, what I should tell you about this experiment is that with this night irrigation we had a relatively lower night dryout in the substrate, which have been affecting the root growth, and your healthy roots is your healthy future. If you have no roots, then you have no fruits. Then we coupled it up with the subflow into the leaf. So we put two subflow sensors, which are also available. If you really want, you can get it from Aranet, and you need to ask for integration, but it's not difficult to do because Aranet is really easy and open for such things. We thought, okay, maybe we could measure subflow changes and reasonable subflow changes to the leaf when we do the night irrigation. But also there, if we measure water in, water out, so there were no changes. So there, if the hypothesis is that by night irrigation we are unloading sugars from the leaf, then it's also not true. And if we would see more subflow towards the leaf, that would mean that there is less water in the leaf, and it is remaining there, but as there is circulation, so night irrigation doesn't do a thing in this case. So important thing is to know your temperature in the greenhouse. Usually what happens with in most of the cases in the greenhouse, you have one sensor somewhere in the middle of the compartment which is measuring for your temperature and relative humidity, and for that one you know your values, and then most of the cases you're happy because you have reached your, let's say, 16 degrees in the night, 22 degrees in the day. But then if you look in the temperature map, you see quite some difference in it. And the difference in the temperature and in humidity can lead you to the understanding why in some corners of the greenhouse, whereas lower temperature and higher relative humidity, you get some fungal diseases on the plant. Like in cucumber, it's Mycosporella, and it happens when you turn on your lights and temperature starts to increase. Those plants are in a lower temperature, the plant itself is cold, and you get it gets in a dew point temperature, and you get possibilities for fungal diseases to grow. So it's a good indication, and it's easy to install it's easy to make temperature map also now in Aranet cloud, where you can make a picture of your greenhouse, put it in the cloud, and put the sensor where you have it, and then you will have overview where is which temperature, and you can choose which units to see. And as it is easy to install, I see more and more of our customers going for temperature map, and now at the moment we have only one customer out of many who doesn't have the temperature map. Which is also good to measure is not only the root zone temperature, but the hypocotyl itself. Because if we talk about cucumber and varieties which are good in yield, like Imea, and but which are bad in Mycosphorella, then you should know that you can measure also the hypocotyl temperature, and you can already predict which will happen in what will happen in greenhouse. We have been measuring temperature which goes in a substrate, so then we know exactly what water we irrigate, and then what happens with the plant temperature itself. And there we see that if we irrigate with a cold water, and it's relatively cold for the plant, we see also the changes in stem temperature, and as there is also relative humidity and air temperature measured next to the and above the plant, we also see that it have influences on air temperature around the cube, so the colder water gets transpirated. But that was the correlation that we see between irrigating with cold water and the air temperature. And then from that one, you know when your plant can get in a dew point, and you can adjust your irrigation temperature. That will give you a lot of valuable lessons just to monitor the irrigation water temperature, which is easy to use with the temperature probe sensors. Then there have been presentations about that we have get reasonable yield increase, and we get more than 20% yield increase. I have seen also a question online about how you can get 20% yield increase, and the easy answer is start with a low base value, and then it's easy to increase the yield. But the project where we got this yield increase of 20% was one of the first, our first 100% LED greenhouse for cucumber growing, and it was built in Latvia. We were struggling to get yield.
Did you start low, Andri?
No, we were planning high, and we started this greenhouse based on research in Warsaw University, how to grow cucumber with LED. We started with high expectation, but with low yield, and we couldn't explain why. And then we decided, okay, let's go for sensors, let's go measure why we cannot get the yield. And 2017 was starting year, and we took as a base point 2018 after first season of the cucumber. And there, problem was that water uptake was limited. We saw temperature which is sufficient, we saw relative humidity which is sufficient for cucumber growing, but the yield wasn't there. Then in the end of 2019 we invested in sensors, and the things what we saw that our temperature readings from the climate computer were wrong. We were reading lower temperature as it was, and we were reading lower humidity as it was. So we were steering based on humidity what we saw from the climate computer, but in reality the greenhouse climate was drier and the stomata were closed and we couldn't get the transpiration. So then we installed the sensors, and then we started to make adjustments in the climate. So in the first year we went to from 123 kilos to 135. The second autumn-winter crop was the learning curve, and there we saw what we could do better. But then in 2020, by measuring the subflow, measuring stem diameter, measuring temperature, measuring air humidity, EC in the substrate and irrigation, gradually, week by week, we increased yield. And we were not just lucky. We were not skilled. We gained our knowledge, and we gained our skills. We were measuring the things what have been happening in the greenhouse, and we got from 71 kilo in 2018 to 110 kilos in the crop in 2021, and we did it with crop which was growing in the greenhouse for 26 weeks with 23 weeks of harvest. So we have relatively long crop. And then autumn-winter crop, there our limitations are, and we know the limitations, so we are losing around 15 kilos just by the climate computer errors with problems with keeping humidity and temperature. So we can estimate our losses, but already with all those losses we know that we can do better, and we're already having increased yield. Then quite often we hear, why did you invest in sensors if there's already climate computer what you could steer? But the answer is short. It's good that you have climate computer. First, when the cars were invented, they didn't have the windshield. They didn't have the wipers on a windshield, and it was nice to drive, but it's kind of difficult. But then when you invented windshield wiper, it started to become easier to drive. And it is the same by using sensors. You know exactly what you need to do because you have a field of view, you see what's happening in the greenhouse. Yes, we invested around almost €5 per square meter, but the payback of it was really quick. We invested €4.5 and we get €60 income, and the payback of this whole investment was around 3 months. And so, of course, we could do maybe it with someone else, but Aranet was an easy choice for us because they had sensors what we needed to have. So we got there, and that concludes my presentation. I hope you enjoyed it. I hope you had the questions, and if you have some questions, then please ask, and Gins will give them to me because I have a...
So perhaps if you can just go one slide back to the concluding information with the financial figures, right? So it appears that agronomists' everyday life is highly complicated from all the parameters I've seen in the graphs, right? So, but then again, at the end of the day, it all comes down to the numbers and kilograms per square meter and euros and productivity increase, right? So, Andris, what you're basically stating is you managed to increase income to €60 per square meter. In addition,
it's addition to that what we had.
Okay.
Without increasing the cost, because actually we have been cutting the cost because we have been heating less, lighting less, venting less. So that means we saved on energy, we saved on electricity, we saved on fertilizers, and we get yield increase. So I am calculating this extra added income just by the kilos that we added by the market price at what we are selling. I'm not talking about the savings what we had, because for that one is that's another story which have now really important impact now. As we see now, the energy prices are going up, and market prices doesn't change so quickly as energy prices, so the cucumber and tomato prices. This year in another project in Latvia with the use of Aranet sensors, we were growing at lower temperatures, allowing plant to heat up with the with natural light, and we saved around minimum was 5%, but I need to look in numbers exactly, but minimum 5% of gas without losing any kilos. So it is easier to grow if you know what's happening in the greenhouse. So you need to see your plant, and then you can make decision based on it.
So it all comes down to either increasing productivity and yield, or saving some costs, right? And you're saying that both is possible with Aranet sensors. So, but when you calculate, right? When you do a calculation, then greenhouse is quite a large place, right? So, and with lots of square meters, right? So, and we are speaking about tens of thousands of euros that you managed to earn in excess thanks to Aranet sensors, and of course thanks to your wise and smart way of adapting your growing strategy, right?
And that's one thing, but Gins, you also would need to keep in mind there's less and less growers available. And the project, before I returned back to Latvia, I have been managing 105 greenhouse hectare in Russia. And because of the lack of the skilled labor, our choice also was for Aranet. So I can monitor larger area. I was responsible for growing in 105 hectares. So to get rapid information about what's happening in the greenhouse, you need to see what's happening there. So by sensors, you can also solve the problem of going in greenhouse and see the crop. Of course, you need to go and see the crop, but if you don't have a time to go to see the crop, you can see it in a digital means. You can see it in graphs. So, and then when you learn from sensor readings, and then when you compare sensor readings with the crop, how it looks like, then you get more knowledge, and that refers to one of the first slides when you can get the wisdom how to grow. So we move away from green fingers, so-called green fingers, to digital thinking of the plant, because that's a mathematical equation.
Okay, thank you very much, Andri, for your insights. I believe it was very useful information for all horticulture companies, prospects, growers participating in this webinar. And I believe we can now go to the questions and answers stage. First, let's answer the questions which were submitted before the webinar, right? So let's, I guess that we already at least partially answered the first question. Is it possible for everybody to get a 20% yield increase? And probably it is really dependent on your current growth efficiency and strategy. But as a general rule, I guess that we can state if you use more sensors, if you have more denser measurements, you come up with data inputs, and these can then be transferred into meaningful insights and actions which will help you to increase your yield levels, right? So,
yeah, to rephrase it, I know growers where it will be really difficult to increase yield by any kilo because they're already at the top level. But I am talking that if you are average grower, if you are starting grower, if you have less experience, if you are new to business, for you to get to those 80%, which is 80% for some, it will be easier to get with sensors. And then if you want to surpass those 80%, or you need more years, or you can buy your time by using sensors. You invest in sensors, and then you can increase yield. But like knowing growers in the Netherlands who are growing 115 kilos of tomato, those are figures which are far out of reach for most of the growers with who I am working in other countries. And for them, they can get closer to that level by explaining why they cannot get this yield. So the temperature limitation, humidity limitation, irrigation strategies. So that's the ones who don't have the yield, they can increase.
Yeah. And probably for some, the yield might substantially exceed 20%, right? So
true.
But so I guess this question is answered hereby. So next question: how accurate are Aranet sensors? And here, in general terms, I can comment that all our sensor data sheets are available on the website. And by the way, we will be sharing these answers in written form after the webinar with all corresponding links. But in general, can we say that accuracy of Aranet sensors is in line with the requirements of horticulture industry?
I think about one of the facts which speaks about the precision is that Priv has chosen Aranet as their preferred sensors. But from our experience, we have been comparing them with certified sensors, which are used to calibrate the greenhouse sensors, and there we see that accuracy is within 0.1 degree and within 1 to 2% of relative humidity, so they are quite accurate. For the scales, we see that it's not on 100 kilo scale, it's not more than 20 grams, the fluctuation. So they are more than necessary accurate for needs in horticulture.
So to shortly answer question, how accurate are Aranet sensors? They are accurate for agronomists.
Accurate.
Yes. Does Aranet have load cells? That is the next question. So we have experience supplying load cells into other industries, and we are also considering adding load cells to our product portfolio at the moment as a standardized product. But please, if you have particular requirements, contact us, and we will work on a proposal for you. Answer is we can supply load cells. We have this experience and capability, but it's not yet available as standardized product. Another question. Would there be plans to release a soil moisture probe which measures at multiple soil depths with one probe? And the answer to this is that we are aware of such multi-layer temperature measuring solutions, and we have some in mind. We are looking into developing such a solution. Please contact us for any immediate project needs, and let's discuss what is possible. Next question. How many EC and moisture sensors are required per 40 times 10 meters surface?
Do we have another half an hour to dig deeper?
I'm afraid we don't have another half an hour. Do you have like a very general answer?
General answer would be minimum 3 EC sensors per irrigation valve. One is sufficient if you measure differences in between the substrates in any other means, but if you have 3, then if 3 of them are in line, in trend or in EC measurement, then you are good. If they start to deviate, then you start to do another measurement. So
okay.
1 is absolute minimum, 3 is minimum.
Okay. And if you have another few hours, please reach out to us, and we'll try to address at some convenient point in time. Next question. This is a technical one. How should one convert PAR to DLI? So PAR to daylight integral, and what are desired daylight integral per crop? So our main crops are poinsettia, pelargoniums, New Guinea impatiens, begonia, and Kalanhoi, right? So, Andris, do you have any recommendations?
Do we have another hour? The short answer to convert to DLI, if you work with artificial light, you take your PAR, you multiply with 0.0036. That will be going to from micromole per square meter per second to mole per hour, and then multiply with hours what you have used. Another step, if you have sensor readouts from Aranet, then you take the micromoles, multiply with 60, divide by million, 60 seconds per minute, and million micromoles per mole, and then you sum it all together, and you have your daily light integral.
We will send out answers to these questions, also containing a formula.
I think I will add some useful links for those ones who are interested in about where to get information about DLI, because our main crop is tomato and cucumber. We know with cucumber we can go with 8 moles per day. That would be minimum. Tomato minimum 12. Optimum is for tomato is around 60, but for cucumber the maximum is 60 moles per day if it's in controlled environment. So the range is wide, and each situation needs different attention. So I think I will add useful links to information.
That would be very good, Andrew, very helpful. Thank you. How to best apply sensors for measurements in 10 liters tough pot?
Well, any measurement in any given volume is better, and the most precise is to measure by the change of weight, because the water, we know that 1 kilo is 1 liter, and the pot volume we know, and then changes in weight will be changes in available water. Different question is where this water is, or in the top or in the middle of the pot, or you use multiple sensors, soil wetness sensors or EC sensors, or the best would be to wait.
Okay, thank you. Next question: how would you suggest setting up the distribution of sensors in bay type greenhouse? I can answer this one, right? So the sensor distribution in bay type of greenhouse does not differ from conventional greenhouse type, which happens to be called Venlo, right? So am I right, Andre?
Rightish.
Rightish. I'm rightish. Okay. So no particular suggestions.
Based on the need, what you want to measure. If you want to measure temperature, make a temperature map. It doesn't differ. You can make vertical temperature map. You can make horizontal temperature map. You can weigh the plant. Based on the needs. It depends on what you want to measure.
Okay. Good. Good. There is a question how to fight against Ralstonia. Which supposedly is a disease, right?
Which is not really the question of the sensors, but my recommendation would be to clean out, sweep out, and take GSPP protocol for cleaning of the premises, clean it out and start from the fresh material. I didn't have a good experience with fighting against Ralstonia because it's easy to spread and you'll notice it too late.
Okay. So let's wish we do
wish
not face with this disease, right? So. Okay, next question. Is there a low-cost technology package for food production in an extremely hot climate? What factors are they monitoring? I guess that answer would be we recommend to go with the basic set of sensors. So
again, based on needs, it is wise to measure the things that we can control. If we can control ventilation, it's wise to measure air temperature because we will influence the air temperature by ventilation. If we can control irrigation, we monitor the substrate. That really depends on what we can control. If it's just plants standing under the foil in open desert, then what stands to measure? Just to give you the pain of that you cannot do a thing about it. No, I think you need to really see what is necessary and what you can control, and then you measure that parameter. And there is no setup, so far as I know, which is meant to low cost today.
Okay, thank you. Last question from the list of questions submitted prior to the webinar. What is the data display dashboard functionality in Aranet software like? So what type of data dashboards are we offering? And I guess I can answer this one, and I will answer in a way that Aranet Cloud offers a wide variety of data visualization possibilities. We will share link to Aranet demo environment after the webinar so that you can see yourselves what the possibilities are. Okay, so now we are past the questions which were asked before the webinar. And although I see that we are a bit over the time, the webinar is recorded, so the attendees who have time, please stick with us for a bit longer, and the ones who have to go, you will have the chance to catch up during watching recording of the webinar, right? So the questions that were submitted, can you please, Andri, can you please repeat again, what device do you use to measure and calculate total inside par when there is LED interlighting?
That is AC hour meter. That one is measuring how long time AC string, so alternating current string, which in our case is 220 volts, is on. So then you know how many hours or minutes, and actually we know in minutes, how many minutes your light were on. I think it is good to add the link to that device. For that question, we will add the link to that particular device that we are using.
Okay.
Because we need to know the status, is it on or off? And if we know that's on, then it's giving us, in our case, 85 micromoles of interlight.
Okay. I saw that there are a lot of questions in chat section.
Now let's go through. I have time because my kids are already at home, so
okay.
We can continue.
Good. Let's continue then. So
should we order pizza?
Is the wet sensor reliable for all kind of substrate or only for stone wool? Now this question relates to our new EC temperature and volumetric water content sensor, and it is reliable in all kind of substrate types, and we can help with the support regarding calibration of the sensor for a particular substrate.
Could I put my part in it? Is that by any means what you are measuring, doesn't matter what you are measuring, there's always error of what you are measuring. If you put any sensor in given conditions, you will measure only those conditions. If you put your wetness sensor or EC sensor in different part of the substrate, you will see different readings. So I would be more looking at how the deltas in the substrate are happening and how they are changing rather than the actual value, because I haven't found any sensor which would be 100% correct, and you usually need to use a common sense as well. So if there is readings which are way off from what you have been expecting, I would be going and rechecking it. But in general, the sensors of the wetness, so the soil wetness sensor we have tested this year in open field in Cucumber, and we are using volumetric water content sensors. They are in line of the spot where we have put them.
Mm-hmm.
So, but then you are interested in deltas.
Yes. Okay. Thank you. Do you also measure chlorophyll of the leaves? Would that be useful?
For that one, we made a third-party integration with SendDot sensors. We measure chlorophyll fluorescence. So we measure photosynthesis efficiency by SendDot sensors, as they have a 4 to 20 milliamp output, and we have been connecting Aranet to SendDot sensor. So that gives you valuable information about the plant activity, which you can use for steering of the greenhouse and the crop.
Okay, thank you. This is a long but I think interesting question, and we can probably spend hours on it, but let me first read it. So, Andris, could you please explain your experience and give opinion on the following point? You showed a lot of graphs at some same screen, and sometimes it is difficult and can be almost impossible to find correlation between parameters and at least useful correlation, right? Are there any algorithms or programs which can help, or probably some automated software or something of that sort? To do instead of man, to do instead of yourself, right? So, do you?
Then it really depends what you want to achieve. There we should distinguish between data visualization and data processing. Where data processing, you need to filter off irrelevant data, you need to filter off the noises, and you need to understand which is signal, which is the noise. So far, automated algorithms for that, so you can train the algorithm, but for that still you need to have a man. That part for automation of the data processing is the one which is a work in progress all the time, because the needs are changing and the sensors are changing. About the data visualization, there are plenty of tools how you can visualize the data. We do our own data visualization and data analysis. We have made our own tools for monitoring the biomass gain and gain over the time, gain over the humidity deficit product with light. We made the composition of different products versus biomass. So that is our specialty. Not only the remote grow support, but we also do a lot of data analysis to find the best ways and the best parameters for growing. There are a lot of work done in Wageningen University. There is the work done in the Technical University of Delft. There are a lot of work done in the United States. There are individual groups and groups of individuals who are working with it. And to be honest, anyone can do it, because I have done it. So I am not a programmer, but I can do it. So everyone can do it.
You have programmed yourself, yeah.
That's true.
That might be challenging for some, but I think that in general this industry is moving towards more supported decision making, right? So by software, by digital solutions, right?
That's true. For that one, the automated solutions yet, which will take the plants in account and steer based on plant needs, are not there. Algorithms which are steering the climate in a greenhouse, they are there. Like Blue Radix offers such solution. You can put your set points, you can put in what is your desired daily light integral, and it's gonna do. Let's Grow does it. Those are two known for me. There are many others who are claiming that they have it. I know two who have things which are working.
Good. Next question, do you have dashboard to control average temperature and parsum a day? As long as I'm aware, in Aranet Cloud such dashboard is not available, but we are working on it, we know about it, and it is in our development plans. Then people like your analogy about the wipers and the windshield. So, yeah, I agree. So, another question. There are several profiles for different substrates, as well as we offer customers. Okay, so that's just information about substrate centers, right? So,
what is good that you have raw value of this sensor, which you can later on recalculate when you know those values. So if you have found the calibration constant, then even if you don't have right interpretation of that at the moment when you have measured, but you have bulk value, which you can later on interpret in the right way.
mm-hmm.
That's what we have done with some of the substrates, just to find reasons for some physiological problems in the plant.
Is substrate temperature a better measurement than using air temperature for setting strategy for strawberries?
Root temperature.
Substrate temperature is substrate temperature better measurement than air temperature for strawberries?
That's the good question. For that one, you need to distinguish between everbearers or June bearers. You need to distinguish whether you're going to do the frigo plants and then putting them in the greenhouse, you will overwinter them in the greenhouse. Root temperature, you need to monitor for the root growth and root activity, where air temperature is necessary for, also there you need to distinguish time, day or night. Daytime air temperature will be important for photosynthesis, root temperature will be important for the water uptake. Below 18 degrees Celsius in root zone, phosphorus gets less available, and by decrease in temperature, more minerals becomes less available, and some of them becomes unavailable at all below, if I remember correct, 10 degrees. And for that one, you need to measure separately air temperature from the root temperature, because if your air temperature is increasing, humidity is decreasing, your water consumption will increase, which can increase EC in the substrate if the root temperature is low. So you need to monitor both. I would recommend to monitor both, because if your roots will be cold, then they will not grow.
Okay, thank you. What is your recommended update interval for the sensors? And do you go for smaller time intervals, for example, for temperature, and longer time intervals for PAR?
No, there is no too short period. But I use the minimum possible. It's 1 minute.
Mm-hmm.
If it will be open field where I cannot control, but I need to monitor, it will be 10 minutes. Like we have done a trial this year with an open field cucumber, and there we did 10-minute PAR, and then we did 10-minute. We did 1 minute PAR, but 10-minute temperature. We need to know the light sun, but we cannot influence the temperature. The fluctuations in air temperature will not happen so dramatically, while sun can change a lot.
Mm-hmm. Yeah.
So the better in greenhouse industry, you go to the minimum time period you can, so 1 minute or lower.
Mm-hmm. What software tools do you use to analyze these Aranet data and your crop's performance? Your own software?
The good thing is that Aranet now have a cloud API. It's easy to get your data out, so it's also near real time. So you get every minute. So as soon as the data Aranet base station gets update, also the cloud gets update, and then depends how you build it, or you use API, pull API or push API. You can use MQTT, which gets your data out immediately when they are, and then you can integrate it or with you can integrate it in Reader, you can integrate it in Priva, you can integrate it in Let's Grow, you can integrate it in any data platform what are, or you can make your own tool. I made my own tool.
Mm-hmm. Yeah.
But you can use any tool available at the moment because you can digest all the data in.
Mm-hmm. Yeah, I think that in general, horticulture industry is about being open and flexible and integrating the data into different types of platforms which offer different types of adapted solutions for specific needs, right?
For that one, the good analogy would be Android and Apple. If we would compare Let's Grow and Hogendorn, those are Apple, they're closed and they would like to keep everything to themselves and not sharing to anyone else. And then Reader and Priva, they're open to community, and you can consume and digest Priva data and Reader data, and you can implement any other sensor data. But openness is just helping us to grow. I don't know anything. I don't know everything. I know a lot, but still I communicate with many other like researchers. I communicate with the consultants, and I share openly because sharing is the only way how we can grow all together. And if we will be just keeping it, this knowledge to ourselves, we will be. If we would do it in regular basis, we still would not have any engines. We would still ride on horses, and we would not have the wipers on the windshield.
Good point. Good point. Okay, so then there's a question which is sort of also relevant for discussion, whether Aranet is compatible with other automatic software like Priva software, and here I would like to state that we have integrated with Priva. Priva was, I think, one of our first integrations. We have a serious partnership with Priva. They have classified our sensors as their primary wireless sensor choice and selection, and Priva is also reselling Aranet sensors, so you can also purchase Aranet sensors from previous resellers.
But there you need to divide control and monitoring. Like greenhouse control still happens with a climate computer. With Aranet sensors you can monitor better and make better decisions how to control. And that's why the integrations are important. And you cannot compare because Aranet is not steering the greenhouse climate. But you can use Aranet to make a better decision.
Yes, Andrew, but I would probably like to shortly add here that we are working with several companies, with several climate computer vendors to enable process control over Aranet sensors. It's work in progress, but it is coming, and it is, I guess, next step for use of Aranet sensors. So, okay. Daylight integral function is going to be okay. Sorry, that's about Aranet Cloud and daylight integral functionality that I already commented on. What is the best tomato yield in a greenhouse? Square meters per year based on your experience. So what is the best tomato yield?
So far it's 120, more than 120. It was 126 if I remember correct. It was done in a Nunems. In Nunems and Bas van Nunems with variety Provine. Commercial growers getting 115 kilos of Merlis. Okay. Yield increase after that point is really difficult, and there you need to be really precise in a steering and data analysis. There you really need to be on spot with light temperature ratio. You need to be on spot with irrigation and fertilizers, because any error will get you off the track.
Okay, thank you. Which parameters do you take into account to give an irrigation shot at night based on Aranet sensors?
No, we don't do shot at night. that was error. So that doesn't give any advantage. If so, when you would give the night irrigation, that would be the period when you had a lot of light during the daytime, and it's dry outside and dry and warm outside. And when your substrate, when your EC starts to increase in substrate, because change in 1 unit of EC have a greater impact of water availability than change in 10% of substrate saturation. One should give irrigation only then when EC is increasing, not to give the water, because for the plant in the dark time, in the night time, the water is readily available as long as the EC is decreasing or remains in the same level. So I will not recommend to give a night shot in most of the cases, and only in limited cases there when it's necessary.
Okay. Thank you for this answer, and I see some other comments, thank you words in the chat, and some other questions that have already been answered in written form. So I guess that, Andrew, we are through the questions. It has been quite in excess of planned 1 hour, but I think lots of useful insights and information. And if you have any further questions, please feel free to contact Aranet sales team with those, and we will address offline. And for now, thank you very much. And Andris, thanks a lot for joining us.
Thank you.
Very interesting.
It was nice to have you. See you some other time.
Thank you. Bye-bye.
Bye.